Okay, so this is less than 7.1. It's the area between two curves. The only difference between this and what we've done area-wise before is that now we're going to look at the area between two curves instead of the area between a curve and the x-axis. So most of the time we're going to have to graph. This is almost an unusual problem, but we've got y equals x, which is right here, y equals x, and we've got y equals x squared, which is going to be this parabola right in here. Now, since we're going from 2 to 4, though, we're looking at right here over. So it's a very strange looking slice. Okay, and really the only important thing we need from this at all is just to know which of the curves is above the other. So we're going to do, the process for this is just going to be top minus bottom. So top curve minus bottom curve. So in this slice, our top curve is x squared, and our bottom curve is going to be x. And that's only from 2 to 4, so it's a very unusual little slice. Okay, and we're going to integrate that, because when you integrate you find areas. So we're doing top curve minus bottom curve, and we just need to know from where to where. So we look at our left boundary and our right boundary. So we have 2 and we have 4. And other than that, we're just going to integrate this, plug in the 2 and the 4, subtract, and get our answer. So let's switch over. So first of all, we're going to integrate x squared minus x. So that's going to be x to the third over 3 minus x squared over 2, and we're integrating from 2 to 4. So I'm going to plug in 4 first, which would be 64 thirds minus 16 halves. And then when I plug in the 2, I'm going to have 8 thirds minus 4 halves, which is 2. So I've got 64 over 3 minus 8, and then minus 8 thirds and minus 2 is inside there. So I'm going to have, okay, so I'm going to have 64 over 3 minus 8 over 3 plus 2, because you have to distribute that negative. So that's going to give me 56 over 3 minus 6. So let's see. Let's follow this up here. 56 over 3 minus 6. And if you get common denominators and all that jazz, you end up with 38 over 3 for your area. Now we know that's like square units, but unless they give you units or ask you to find the units, you don't have to worry about putting in the units. So the area between these two curves is going to be 38 over 3. Okay, so let's look at another example. This time, we're not going to draw the picture. So this time we can go through kind of, I think of it as sort of a formula. So I'm going to draw for you. We know we want to use the top curve minus the bottom curve. And on our integration, this is going to be whatever is the left x value, and this up here will be the right x value. The only problem with this is that we're missing several things. First of all, we don't know what's top versus what's bottom, and we also don't know what's left and what's right. So we have to keep in mind that I'm looking at two graphs that are going to intersect. So if they're going to intersect, then we need to find out what their intersection points are. So how do you do that? Well, we're going to take 1 minus x squared, and we're going to set it equal to 1 minus x, because whenever they intersect, they should have the same y value. So you set them equal to each other. And so what I'm going to do is just subtract 1 from both sides and add x squared to both sides. So I'm going to have 0 equals 0 minus x plus x squared, so I'm just going to write it as x squared minus x. Then if I factor that as x times x minus 1, then that gives me my two intersection points, because this would be x equals 0, and this one would be x equals 1. So from finding our intersection points, we're going to know that this one is going to be 0, and this one is going to be 1. And it's important, if you're not going to use the graph, it's important that you know your intersection points before you do anything else. Alright, so now we know our left x and our right x, but we don't know which is top and which is bottom. So a really easy way to do this is just pick a number between your two intersection points. So between 0 and 1, say we could use 0.5. If I plug 0.5 in here, and if I plug 0.5 in here for x, whichever one is a bigger number is the top curve, and whichever one's the smaller number is the bottom curve. So for this one, this would be 1 minus 0.25, so that would be 0.75. And on this one right here, we would have 1 minus 0.5, which is 0.5, and I know that this is a bigger number, so I know that this is my top curve and this is my bottom curve. Now I've written all over this and got, oh, the B didn't show up there. Okay, I've written all over this and it looks all crazy, but I'm going to erase a lot of this, there it is, to set up my integration. So if you need to pause for a minute and write this down, go ahead and do that now. Okay, so we know the top curve is going to be 1 minus x squared, and the bottom curve is going to be 1 minus x. We know the left x was going to be 0 and the right x was going to be 1. Those are the things we discovered on our own. So now I just need to simplify it and integrate it and all that. So usually in these problems, the integration is not going to be big. It's setting it up that is the issue. So let's see. If I go from 0 to 1, so I have 1 minus x squared minus 1 plus x if I distribute that negative. So 1 minus 1, so I'm actually integrating negative x squared plus x. So negative x squared becomes negative x to the third over 3, and x becomes x squared over 2, and this is starting to look very familiar to the last problem, from 0 to 1. Except for we like these numbers this time. When you plug in 1, you get negative 1/3 plus 1/2 minus, and then when you plug in 0, you get 0 plus 0. So the 0 part's going to be gone. So I just have negative 1/3 plus 1/2, which is 1/6. So we did not even, and that's kind of hard to see with where I write up here. We didn't even draw the graph on this one, but we were still able to figure out what goes where. And I will say the majority of the time on the AP test, they will give you, if it's a difficult curve, they will give you the graph so that you don't have to figure that out yourself. All right, for this next one, we're going to graph sine x and cosine x, and we're going from 0 to pi over 2. But the thing is, sine and cosine have lots of little intersections. So you can graph it if you want to. Alright, so we know I'm going to do this as my 1. So I know cosine looks like this, and I know sine looks like this. So where is pi over 2 going to fall into this? So for me, I tend to look at, in my head, what my unit circle looks like. And so I'm going to think about, I've got 0. I know 0 has to be one of my starting points. And I know I have to end at pi over 2, but there's somewhere between here that sine and cosine are the same. and that is at 45 degrees, which is pi over 4. At pi over 4, sine and cosine are equal to each other, so that's also an intersection point. So since I have 3 values, I have to make 2 integrals. So I'm going to do an integral that goes from 0 to pi over 4, because sine and cosine intersect at pi over 4, which on your graph over here, there's your intersection. And then I'm also going to have to do a graph that starts at pi over 4 and goes to pi over 2, because even though they don't intersect again at pi over 2, it's actually right in here. Even though they don't intersect again, it is what they want us to stop for our interval. So I've got 2 intersections, and the thing about that is, this first part, the blue curve is above, and the second part, the red curve is above. So not only do we have 3 intersection points, we also have to plug in and see which one's top and which one's bottom based off of the interval. Okay, so from 0 to pi over 4, the blue curve is the top curve, so cosine is above sine. And for pi over 4 to pi over 2, the red one is above, so we're going to have sine minus cosine. Barely squeezed that in there. Okay, so I've redrawn the graphs so we can see it a little bit better. And so from 0 to pi over 4, the blue curve is the top curve. And from pi over 4 to pi over 2, the red curve is the top curve. And now we just have to integrate those 2 things and plug in the values separately, and on and on and on. And also in class I'm going to show you how to do this in your calculator, which will make it a little bit easier. Alright, so cosine minus sine. Cosine integrates to become sine. Sine integrates to become negative cosine from 0 to pi over 4. Then for this one, it's going to be the opposite. Sine integrates to become negative cosine. Cosine becomes positive sine. And this one's going to be from pi over 4 to pi over 2. Now if I'm going to plug in the pi over 4 and plug in the 0, I'm just going to kind of say these. Sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 4 is the square root of 2 over 2. Sine of 0 is 0. Cosine of 0 is 1. So that's all from this grouping right here, is that part. So I'm going to need a place to write this. So pause if you need to and write this down, and I'm going to start with a clean page. Okay, so I had already plugged in the pi over 4, so square root of 2 over 2 plus the square root of 2 over 2 minus 0 plus 1. And now in the next section, when I plug in pi over 2, I'm going to have negative 1 minus 0. No, I said that backwards. Didn't I? Yep, I said that backwards. Okay, so cosine of pi over 2 is 0, so it'd be negative 0, but that's really just 0. Minus sine of pi over 2, which is 1, so that'd be 1. And then again minus. When I plug in pi over 4, I'm going to have negative square root of 2 over 2 minus square root of 2 over 2. And so Here, I have the square root of 2 over 2 plus the square root of 2 over 2. So that makes 2 square roots of 2 over 2. 0 plus 1 is 1. 0 minus 1 is negative 1. Minus the square root of 2 over, the negative square root of 2 over 2 minus square root of 2 over 2 is negative 2 square root of 2 over 2. And then the two negatives will become plus. So I've got negative 1 plus negative 1 is negative 2. And then I have a square root of 2 plus the square root of 2, which is 2 square roots of 2. And that's actually our answer. All right, so the last example I'm going to look at is a little bit different because these equations are x equals equations instead of being y equals equations. So remember that graphing it's almost the same, it's just it's going to go to the side. So x equals y squared goes over here. It's a sideways parabola. And x equals y plus 6 is going to be 1, 2, 3, 4, 5, 6. And when x is 0, y is going to be negative 6. So it's going to be 1, 2, 3, 4, 5, negative 6 stuff there. Okay, so I need to extend my red curve a little bit further here so you can see. Okay, so this changes a lot of things. The most important thing that changes is that we're looking at our curve as if x, let's see what I want to use here. If it's an x equals function, instead of thinking in terms of top minus bottom, we're going to think in terms of right minus left. Because everything we're going to do is going to be in terms of y's now. Because my right curve from my picture is my line, so the right curve is y plus 6, and the left curve is y squared. So since we have y's inside our integration, then over here my limits of integration are going to be y's also. So if it's x's inside, everything's in terms of x. If it's y's inside, everything's in terms of y. And lucky for us, they actually told us where to start and where to end. So we're going to start when y is 0 and go when y is equal to 3. So remember, this now we're talking about is right versus left. Okay? Right versus left. Now, I'm going to integrate this, and we're going to integrate, this will be one that you'll use your calculator for. But we're going to integrate this and get the answer, and we're still good. So in your calculator, even though all these are y's on our problem, in my calculator I can still put them all as x's because your calculator just cares that you use the same variable the whole way through. So I'm going to work that out, and then we'll be done. Okay, so using our calculator, I got 13.5 for the answer. If you have not seen how to do this in class yet, be sure and ask me tomorrow because I will tell you.